A brief introduction of Pakistan Wire Industries Private Limited. Wire manufacturing, from raw material to wire ropes. Wire manufacturing is a meticulous process that involves transforming raw materials into durable wire ropes with specific configurations. This article delves into the intricate details of the general process flow, material characteristics, testing methods, coating tests, heat treatment, and various phase diagrams associated with wire manufacturing. General process flow. The process begins with different types of raw materials such as mild steel, medium carbon steel, and high carbon steel, ranging from 5.5 mm to 13 mm. These materials are graded according to their nominal tensile strength, with high carbon steel grades like 4-2B, 6-2B, 6-7B, and 7-2A being common. Material testing follows, involving tensile, elongation, bending, and torsion tests to ensure the wire's strength, ductility, flexibility, and resistance to twisting. Material characteristics. Understanding the composition and characteristics of the materials used in wire manufacturing is crucial. The materials undergo testing using methods such as tensile, elongation, bending, and torsion tests. Tensile tests measure the strength of the material, elongation tests assess ductility, bending tests evaluate the wire's ability to withstand bending without failure, and torsion tests gauge its resistance to twisting. These tests collectively ensure that the wire meets the required standards for strength, flexibility, and durability. Zinc coating test. The zinc coating test is a critical step in assessing the weight per unit area of the zinc coating on the wire's surface. This coating is essential for ensuring the quality, durability, and performance of zinc-coated materials. Laboratory analysis is a common method for determining the weight of the zinc coating, involving precise steps such as measuring the weight before and after removing the zinc coating. Magnetic thickness gauges are also employed, offering a practical and non-destructive way to measure coating thickness. Heat treatment, patent. The heat treatment, known as patenting, involves subjecting steel wires, including high-carbon steel, to elevated temperatures. This process aims to enhance the mechanical properties of the wires and reduce brittleness. During patenting, structural changes such as grain refinement occur, leading to improvements in the wire's overall strength. Iron-carbon phase diagram. The iron-carbon phase diagram is a fundamental tool in understanding the microstructural changes that high-carbon steel undergoes during heating. Different phases such as ferrite, austenite, cementite, perlite, and martensite play crucial roles in influencing the steel's properties. This diagram provides insights into the transformations occurring in the material at varying temperatures and carbon concentrations. Time temperature transformation, TTT, curves. TTT curves depict the relationship between time, temperature, and phase changes in steel during cooling. Understanding these curves is essential for controlling the microstructure of the steel. Key components of the TTT curves include the nose, C curve, and S curve, each representing specific phase transformations during cooling. Galvanizing. Galvanizing is a protective process where a zinc coating is applied to iron or steel to prevent rust and corrosion. Two main methods, hot dip galvanizing and electro-galvanizing, are employed. Hot dip galvanizing involves immersing the steel in molten zinc, while electro-galvanizing uses an electrolyte solution and electric current to deposit a layer of zinc. Each method has its advantages in terms of coating thickness, corrosion protection, and cost-effectiveness. Wire drawing. Wire drawing is a critical step that involves reducing the diameter of the wire through a series of dies. Key parameters monitored during this process include reduction, the number of dies, lubricant concentration, pH, temperature, and the final wire size. Understanding the base material and the intended final wire size is essential for a successful wire drawing process. Stranding process. The stranding process entails twisting multiple wires together to form wire ropes with specific configurations. Parameters such as meter per minute, pitch, rope diameter, strand diameter, and core diameter are closely monitored. This process is essential for creating wire ropes with the desired flexibility, strength, and characteristics. Wire rope classifications. Wire ropes are classified into different categories such as seal, regular/single layer, Warrington, and combination, each offering specific characteristics. These classifications are based on factors like crush resistance, abrasion resistance, and flexibility. Understanding the distinctions between these classifications is crucial for selecting the appropriate wire rope for different applications. Types of lay-in wire ropes. The two primary types of lay-in wire ropes are regular lay and lang lay. In regular lay, the wires in the strands are twisted in the opposite direction to the strands themselves, while in lang lay, the wires in the strands are twisted in the same direction as the strands. Each type has its advantages and disadvantages in terms of flexibility, kinking resistance, and crushing resistance. Wire rope constructions. Wire ropes come in various constructions, such as 6x19, 6x37, 6x12, and others, to meet specific requirements. These constructions offer different properties in terms of flexibility, fatigue resistance, load carrying capacity, and crush resistance. Selecting the appropriate construction is crucial for the intended application. Core of wire ropes. The core of wire ropes can be either a hemp core or an IWRC, independent wire rope core. Each type has its strengths and weaknesses, impacting factors such as strength, flexibility, buoyancy, and lifespan. The choice of core depends on the specific requirements of the application. Conclusion. In conclusion, wire manufacturing is a complex and intricate process that involves a series of carefully orchestrated steps. From material selection and testing to heat treatment, coating, and the final wire rope construction, each stage plays a vital role in determining the properties and quality of the end product. Understanding the nuances of wire manufacturing is essential for producing wires and wire ropes that meet industry standards and serve diverse applications effectively.